So the way that I would describe Dr. Lai's work to an average person is by starting with the complicated phrasing. That is, he works in the field of nonlinear dynamics and chaos. Complicating, challenging, but foundationally important to all kinds of different applications. That is, he can connect his work to improving the design of a prosthetic device, of a robot. He can help us understand the properties and the ways in which to exploit the properties of quantum materials. He can improve by analyzing and understanding neural networks that in turn lead us to more robust understanding of machine learning algorithms. So in other words, there are a range of applications, and his career is really remarkable in the sense of the many different problems that he has solved.
That's what's really challenging, but also very interesting about the field, and that you really have to be able to jump from one field to another, which is normally thought of as just a single discipline. And so that's what's quite special about Professor Lai's research, of just that cross-disciplinary, interdisciplinary type approach, and being able to see the big picture across many areas where people just do a deep dive into that area and don't realize maybe their work is connected to something else. So Professor Lai is a very accomplished researcher, but he's also incredibly nice.
I'm Ying-Cheng Lai, a professor of electrical engineering, and I do chaos. My research is interdisciplinary, so I got the opportunity to collaborate with different people from different fields. So that really makes my life very fun and interesting. So that keeps everything going, And if you have for instance, a pollinated type of network and a pollen bee and lots of bee and plants type of situation, and then you have a local region, and this region has a bunch of pollinated species. They form a self-evolving dynamical system, and you try to predict whether or not this system will collapse in the future. But because the system is so complicated, there's no way you can get the equations, precise knowledge about the system. All you have is measurements. By using machine learning, we hope that we can predict whether or not the system is going to collapse in the near future.
And so he's really making very important advances in that area of machine learning, specifically applied to these dynamical systems and the data assimilation problem.
He is a role model. He's somebody that we seek to aspire to. That is, for our faculty to see how someone having that success over such a long period of time really makes him a remarkable faculty member and somebody that we're very proud of.